Hello everyone. Now we are going to see a pathway called glycogenolysis. As I have already mentioned, this is a part of glycogen metabolism, and glycogen metabolism is very essential for maintaining the normal blood glucose levels. We have already seen the synthesis of glycogen, that is called glycogenesis, and we will see the breaking down of glycogen, that is called glycogenolysis. Degradation of stored glycogen into glucose is known as glycogenolysis. It is not the exact reversal of glycogenesis but needs a completely independent set of enzymes. The location of this process is cytosol itself. Because glycogen is stored in the form of granules in cytosol, both the synthesis as well as breaking down of glycogen will occur in cytosol. This degradation proceeds by cleaving two types of glycosidic bonds. One is alpha 1,4 glycosidic bonds and the other one is alpha 1,6 glycosidic bonds. 1,4 bonds are used to join glucose molecules linearly in a chain, and 1,6 bonds are used for branching in the glycogen molecule. This is a small representation of the glycogen molecule, a small part. You can see the red bubbles, that is the branching point, and in the yellow box it's written glycogen phosphorylase. Glycogen phosphorylase is capable of breaking alpha 1,4 glycosidic bonds. You can see three arrows there. So from all sides, glucose molecules are removed by breaking alpha 1,4 glycosidic bonds by the enzyme glycogen phosphorylase, and the molecules are released in the form of glucose 1-phosphate and not in the form of free glucose. We will move on. You can see removing glucose residues in the form of glucose 1-phosphate. Now in the square, what remains is a small molecule. From the branching point, it has got only 4 or 5 glucose residues. This molecule is no more called glycogen, but it is called limit dextrine. And this enzyme, glycogen phosphorylase, cannot act on limit dextrine anymore. അപ്പോൾ നമ്മൾ കണ്ടത് ഗ്ലൈക്കോജൻ മോളിക്യൂൾ ആയിരുന്നു. അതിൻ്റെ ഓരോ സൈഡിൽ നിന്നും ഗ്ലൂക്കോസ് റെസിഡ്യൂസിനെ ഓരോന്നായിട്ട് സീക്വൻഷ്യലായിട്ട് റിമൂവ് ചെയ്യുന്നു ഇൻ ദ ഫോം ഓഫ് നോട്ട് ഇൻ ദ ഫോം ഓഫ് free glucose, it is in the form of glucose 1-phosphate. This is done by glycogen phosphorylase enzyme. This process will continue until 4 residues remain on all the sides of branching point. This molecule is now called limit dextrine. Now, to cleave these branches, we have another enzyme that is called a debranching enzyme. Actually, it is a bifunctional enzyme. It has got two functions. We will see. One of its action is called 4,4 transferase action. Bifunctional, രണ്ട് ഫംഗ്ഷനുള്ള എൻസൈം ആണെന്ന് പറഞ്ഞു. അതിലെ ഒരു ഫംഗ്ഷൻ 4,4 transferase. It transfers this fragment of chain of glucose to another molecule or to the same molecule. ഈ റെഡ് ബബിളിലുള്ള ഒരു ഗ്ലൂക്കോസ് റെസിഡ്യൂ മാത്രം ബാക്കി വെച്ചുകൊണ്ട് this fragment is removed and it is joined to another molecule or to the same molecule through 1,4 glycosidic bonds. You can see a last glucose residue is present at the branching point. I told you that it is a bifunctional enzyme. Its second function is to remove the last glucose residue that is released in the form of free glucose. See, it is in the form of free glucose. And the second type of action is called amylo alpha 1,6 glucosidase action. So this 4,4 transferase action as well as 1,6 glucosidase action are given by the same enzyme, which is a bifunctional enzyme. That enzyme is called debranching enzyme. So the branch is now removed. What we have is a linear molecule, and this linear molecule can be acted upon by the previous enzyme, that is glycogen phosphorylase, because this linear chain contains only alpha 1,4 linkages, and this can be easily broken down by glycogen phosphorylase enzymes. And all these glucose molecules are released in the form of glucose 1 6 sorry glucose 1 phosphate. You can get n number of glucose 1 phosphate. Now this glucose 1 phosphate is converted into glucose 6 phosphate by enzyme called phosphoglucomutase. By the action of phosphoglucomutase, glucose 1 phosphate is converted into glucose 6 phosphate. Glycogenolysis can occur in liver as well as in skeletal muscles. So the fate of glucose 6 phosphate is different in skeletal muscles as well as in liver. In skeletal muscles, it enters into glycolysis, and in liver, it forms glucose. What is this difference? Why this difference? We have seen a process called gluconeogenesis. The last step of gluconeogenesis is conversion of glucose 6 phosphate into free glucose. That is done by an enzyme called glucose 6 phosphatase. This enzyme is present in liver, but it is not present in skeletal muscle. So the conversion of glucose 6 phosphate into glucose will occur only in liver due to the presence of that phosphatase enzyme. Since the enzyme is absent in skeletal muscles, it cannot be converted into free glucose. Instead, it enters into glycolysis. The first step of glycolysis is conversion of glucose into glucose 6 phosphate. Then glucose 6 phosphate is isomerized to fructose 6 phosphate. So directly it enters into glycolysis and it causes generation of ATP required for muscle contraction. So the last product, glucose 6 phosphate, it is either entered into glycolysis if it occurs in skeletal muscles, and if it is in the liver, it is converted into glucose by glucose 6 phosphatase enzyme. So step by step process is written here. This is what I explained. And the sequential removal of glucose in the form of glucose 1 phosphate by cleaving or breaking alpha 1,4 linkages is called phosphorylasis. There is a formation of limit dextrin. Then comes debranching. Debranching is carried out by debranching enzyme, which is a bifunctional enzyme. This is also explained. So the last residue on the branch, it is released in the form of free glucose. These activities continue until all the glucose residues are removed. The formation of glucose 1 phosphate and free glucose occurs in the ratio 8:1. glucose 1 phosphate is now converted into glucose 6 phosphate by phosphoglucomutase. In liver, it is converted into glucose by glucose 6 phosphatase enzyme. Since this enzyme is absent in skeletal muscles, glucose 6 phosphate directly enters into glycolysis and produce ATP for muscle contraction. Regulation of glycogen metabolism. Regulation and coordination of glycogen synthesis as well as degradation are essential for maintaining a normal blood glucose level. Glycogen synthase and glycogen phosphorylase are the regulatory enzymes of glycogenesis and glycogenolysis respectively. What are regulatory enzymes? Most of the pathways have many number of enzymes involved in it in different steps, but some enzymes play a key role. By controlling this enzyme, the whole pathway can be regulated. എന്ന് വെച്ചാൽ ഒരു പാത്വേയിൽ പല സ്റ്റെപ്പുകൾ ഉള്ളത് കൊണ്ട് തന്നെ പല എൻസൈംസും ഉണ്ടാവും. എന്നാൽ ഇതിൽ ചില എൻസൈംസ് വളരെ ഇമ്പോർട്ടൻ്റ് ആണ്. ആ എൻസൈമിനെ മാത്രം റെഗുലേറ്റ് ചെയ്തുകൊണ്ട് പാത്വേനെ മൊത്തമായിട്ട് നമുക്ക് കൺട്രോൾ ചെയ്യാനായിട്ട് സാധിക്കും. സോ ദോസ് എൻസൈംസ് ത്രൂ വിച്ച് the entire pathway can be controlled are called regulatory enzymes. In case of glycogen synthesis, glycogenesis, the regulatory enzyme is glycogen synthase, and in case of glycogenolysis, the regulatory enzyme is glycogen phosphorylase. So by controlling this glycogen synthase or glycogen phosphorylase, we can regulate the rate of metabolism of glycogen. So controlling of these two enzymes will occur through three mechanisms. One is hormonal regulation, hormone mediated regulation. Next is allosteric regulation. The third one is regulation mediated through calcium ions. Hormonal regulation. In short, the overall effect of hormone regulation of glycogen metabolism is that the elevated glucagon or epinephrine levels will increase glycogenolysis, that is degradation, whereas elevated insulin level will increase glycogen synthesis. When we look at the function of insulin tend to reduce the blood glucose level. So to reduce blood glucose level, the extra glucose is converted into glycogen and it is stored. So for this conversion, we need an enzyme called glycogen synthase. So insulin will be promoting the action of glycogen synthase. Glucagon is having an opposite action to insulin. You have already seen in HAP and all, glucagon and insulin, they will act in opposite directions. Insulin will reduce blood glucose level, glucagon will increase blood glucose level. Now when glucagon is released, the stored glycogen is depleted through glycogenolysis to release more glucose. Also see epinephrine. Epinephrine is a hormone released during an emergency situation of fight or flight. So in this emergency situation, we need more glucose in our blood. So what epinephrine will do? Epinephrine will promote glycogen phosphorylase enzyme, which will provide more glucose to the blood by carrying out glycogenolysis. Glucagon and epinephrine they will positively act on cyclic AMP. They will promote the formation of cyclic ANP that occurs by activation of an enzyme called adenyl cyclase, which converts ATP into cyclic ANP, and that details are not included here. You just remember that glucagon and epinephrine will increase the synthesis of cyclic ANP. The cyclic AMP will activate protein kinase. When protein kinase is activated, glycogen synthase is inhibited. When protein kinase is activated, glycogen synthase is inhibited. When this enzyme is inhibited, glycogenesis is also inhibited. Next is allosteric regulation. Certain metabolites can allosterically regulate activities of glycogen synthase as well as glycogen phosphorylase. Allosteric enzymes. These enzymes are allosteric enzymes. Glycogen synthase അതുപോലെ തന്നെ glycogen phosphorylase എന്ന് പറയുന്നത് ഒക്കെ allosteric enzymes ആണ്. What are allosteric enzymes? You know that enzymes have got an active site for binding the substrate. And allosteric enzymes have other binding sites in addition to the active site for some other molecules. ഒരു എൻസൈമിന് ആക്റ്റീവ് സൈറ്റ് എന്ന് പറയുന്ന ഒരു പോർഷൻ ഉണ്ട്, അവിടെയാണ് അതിൻ്റെ സബ്സ്ട്രേറ്റ് ബൈൻഡ് ചെയ്യുക. എന്നാൽ അലോസ്റ്ററിക് എൻസൈംസിന് ഈ ആക്റ്റീവ് സൈറ്റ് കൂടാതെ വേറെയും ബൈൻഡിങ് സൈറ്റുകളുണ്ട്. ഈ ബൈൻഡിങ് സൈറ്റുകളെല്ലാം സ്പെസിഫിക് ആയിരിക്കും മറ്റ് ചില മോളിക്യൂൾസിന് വേണ്ടിയിട്ട്. സോ ദറ്റ് എൻസൈം ഹാവിങ് more number of binding sites, they are called allosteric enzyme. Glycogen synthase and glycogen phosphorylase are allosteric enzymes. They have binding sites for many other molecules. Certain metabolites allosterically regulate the activities of glycogen synthase and glycogen phosphorylase in such a way that glycogenesis is increased when substrate availability and energy level are high, and glycogenolysis is increased in the reverse condition. നമ്മളുടെ ബോഡിക്ക് ആവശ്യത്തിൽ എനർജി ഉള്ള ഒരു കണ്ടീഷനാണ് എങ്കിൽ, അതുപോലെ നമ്മളുടെ ബോഡിയിൽ ഗ്ലൂക്കോസ് എന്ന് പറയുന്ന മോളിക്യൂൾ വളരെ അധികം ഉണ്ട് എങ്കിൽ എന്ത് സംഭവിക്കും? എക്സസ് ഓഫ് ഗ്ലൂക്കോസ് ഈസ് സ്റ്റോർഡ് ഇൻ ദ ഫോം ഓഫ് ഗ്ലൈക്കോജൻ. ഫോർ ദാറ്റ് glycogenesis is initiated. Opposite condition ആലോചിച്ച് നോക്കുക. Low energy level. We need energy. If you need energy, you need more glucose. If you need more glucose, glycogen should be broken down to release glucose. So, low energy level condition will promote glycogenolysis. Influence of calcium. During muscle contraction, calcium 2 plus ions are released from the sarcoplasmic reticulum. This will bind to calmodulin protein and it will directly activate glycogen phosphorylase enzyme. This will increase the rate of glycogenolysis. സോ മസിൽ കൺട്രാക്ഷൻ്റെ സമയത്ത് കാൽസ്യം കൂടുതലായിട്ട് റിലീസ് ചെയ്യുന്നു. കാൽസ്യം 2 plus ions, they will bind with a protein called calmodulin. This will directly activate phosphorylase, glycogen phosphorylase enzyme. So more and more glycogen will be depleted to release more and more glucose. മസിൽ കൺട്രാക്ഷൻ എന്ന് പറയുന്നത് എനർജി ആവശ്യമായ ഒരു അവസ്ഥയാണ്. അപ്പോൾ ആ സമയത്ത് മസിൽ കൺട്രാക്ഷൻ്റെ സമയത്ത് എക്സസ് ആയിട്ട് റിലീസ് ചെയ്യുന്ന കാൽസ്യം, എക്സസ് എന്ന് പറയാൻ പറ്റില്ല, മസിൽ കൺട്രാക്ഷൻ്റെ സമയത്ത് റിലീസ് ചെയ്യുന്ന കാൽസ്യം കാൽമോഡിലിൻ എന്ന പ്രോട്ടീനുമായിട്ട് ബൈൻഡ് ചെയ്യുകയും അതുവഴി ഡയറക്റ്റായിട്ട് ഗ്ലൈക്കോജൻ ഫോസ്ഫോറിലേസ് എന്ന് പറയുന്ന എൻസൈമിനെ ആക്ടിവേറ്റ് ചെയ്യുകയും ചെയ്യുന്നു. ആ എൻസൈം ആക്ടിവേറ്റ് ആയി കഴിഞ്ഞാൽ ഗ്ലൈക്കോജൻ സ്റ്റോറേജ് ഡിപ്ലീറ്റ് ചെയ്യാൻ തുടങ്ങും, ഗ്ലൂക്കോസിനെ റിലീസ് ചെയ്യാൻ തുടങ്ങും. സോ ദാറ്റ് ഈസ് ദി എഫക്റ്റ് ഓഫ് കാൽസ്യം അയോൺസ്. ഇറ്റ്സ് എ ഡയഗ്രമാറ്റിക് representation. ATP, high ATP level and high availability of glucose 6-phosphate, etc. Also glucose in liver, in case of liver, glucose will negatively affect glycogen phosphorylase. Imagine you have more ATP, so energy is not needed. You have higher concentration of glucose or higher concentration of glucose 6-phosphate. All these situations will negatively affect glycogen phosphorylase. ഗ്ലൂക്കോസ് ഇഷ്ടം പോലെ ഉണ്ട്, എനർജി അവൈലബിൾ ആണ് ഇഷ്ടം പോലെ. അങ്ങനെയുള്ളൊരു സമയത്ത് ഇനി കൂടുതലായിട്ട് ഗ്ലൈക്കോജൻ്റെ ബ്രേക്ക് ഡൗൺ നടക്കേണ്ട ആവശ്യമില്ല. സോ ഇറ്റ് വിൽ inactivate glycogen phosphorylase and it will block this process. On the other hand, ATPക്ക് പകരം AMP ഉണ്ട് എങ്കിൽ that will positively modulate conversion of glycogen into glucose 1-phosphate. കാൽസ്യത്തിൻ്റെ കാര്യം നമ്മളിവിടെ പറഞ്ഞു കഴിഞ്ഞു. ഇൻഫ്ലുവൻസ് ഓഫ് കാൽസ്യം. Calcium will bind with calcium released during muscle contraction will directly bind with the calmodulin protein that will activate glycogen phosphorylase. Please see a correction in the spelling of muscle. ഒരു C അവിടെ മിസ്സിംഗ് ആണ്. Please correct it. These molecules, glucose 6-phosphate and ATP, which will negatively affect phosphorylase enzyme, will positively affect glycogen synthesis. So we have a higher concentration of ATP, no more energy is needed, so the excess of glucose available is converted into glycogen and it is stored for the future purpose. So that is the 3 types of regulation of glycogen metabolism. Glycogen metabolism രണ്ടെണ്ണമാണ്, അതിനകത്ത് 2 പാർട്ടാണുള്ളത്. ഒന്ന് സിന്തസിസ് ഓഫ് ഗ്ലൈക്കോജൻ, രണ്ടാമത്തെ കൗണ്ടർ പാർട്ട് ഡിപ്ലീഷൻ ഓഫ് ഗ്ലൈക്കോജൻ to glucose 1-phosphate. Synthetic process is called glycogenesis. Depletion is called glycogenolysis. 3 types of regulations are present: hormonal regulation, allosteric regulation, and regulation mediated through calcium ions. Calcium ions calmodulin bind ചെയ്യുന്നു. Directly it activates glycogen phosphorylase. So during muscle contraction, more and more of calcium ions are released, more and more glycogen is broken down into glucose 1-phosphate. ATP levels are high, glucose levels are high, so no more energy is needed. It will deactivate this process. ATP high, glucose 6-phosphate high, no energy is required, so for the future purpose glucose is converted into glycogen. And hormonal regulation, glucagon and epinephrine will activate protein kinase through cyclic ANP. This will deactivate glycogen synthase enzyme that will cause inhibition of glycogenesis. Thanks for watching the video. Good day.